Hey, it's Greg again, and in this episode we are going to talk about the star schema in Power BI. We will cover the what, why, and how of it so that you know exactly what a star schema is, why is it important in Power BI, and how can you create it, how can you manage it in Power BI in the simplest way possible to start with. With that in mind, let's get into it. So let's start by discussing what a star schema actually is. For this, I have prepared a short demo data set, which includes sales data, the sales value by continent, country, the category of the product, brand of the product, specific product, so product name, and the year. So you could say, hey, this is not a star schema, and certainly it's not. This is a flat table schema, so just your one big table with all the data inside the year, the product name, brand, and so on, and the sales as well, so some kind of decimal data. But you could say that, hey, yeah, it's all the data in one, but this comes from different domains actually. So for instance, those three columns, let me highlight them, are talking about the product and its attributes, while some other ones, some other columns, like the country and continent, are talking about a bit of a different entities. So yeah, exactly. And this is actually where we are going towards the star schema. So for the product related columns, we have three here. We could say that, hey, the product name is actually the name of the specific product that we are talking about in this row. So for this combination of product, year, and country, we have this sales value. So this much was sold. But the brand and the categories are really just attributes of the individual product name. Why? Because the brand will always stay the same, at least conceptually, for a given product. So for this specific product, our digital camera, the brand will always be the same. It will be a datum. Same goes for product category, because one product, specific product to be precise, can only belong to one product category at a time. And you could have much more examples here, like the manufacturer name of a given product, like the barcode, or something like that. So we could say that if you could somehow memorize that for this product name, the brand is a datum and the category is cameras and camcorders, then we no longer really need those two columns. We could hide them and maybe put some kind of mapping in a different table that this product name corresponds to this brand name and product category. This would be a kind of a dictionary and a dimension to call it, specifically in star schema. While what we have left would be something that we would call a fact. So a fact is an individual transaction for a given year, product name, country, and so on. But hold on, we've got some more redundancy here. We could say that the country and continent are really kind of speaking of the same thing, of the location, you could say. And moreover, you could note that, well, the continent is really an attribute of the country. So for a given country, the continent is always the same. So yeah, the same goes here. From these two tables, we could create another dimension or dictionary, which would say that for a given country, we have this continent. And if we now would hide the continent column from the main table, we suddenly have just 4 columns here, which is much less in size, so we need much less storage space to accommodate your data. And it also helps Power BI work better. So what's in the star schema for Power BI? You need less storage space for your data, the same volume, and also Power BI specifically designed to work correctly in a star schema model. So it will produce the correct results and be very fast if you adhere to the star schema. If you go for something like a flat table or snowflake schema, it may no longer be that good. With that, let's go to a demonstration in Power BI to see what and how can you create from such a data. Okay, I will connect to my data source, which is exactly the same data, but just more of it. In a CSV file, we will just have a bit over 1,000,000 rows instead of just a few that we had. Okay, let's let it connect, and I will show you how to create a star schema from such a data quickly. So what you can do is, well, you could rename this to a reference. So our first data table is called reference. We will just be referencing it by the dimensions and facts. So let's start by doing the production dimension. So for the sake of the naming convention, I will call it dim, like a dimension, and I will call it product. So for the product, we need just 3 columns, the ones that actually are attributes related to products. So the product name, brand, and category. We can remove all the others. And we can also remove duplicates from this table or from just the product name column. And great, now this is our dictionary or dimension of products. So each product name will be stated here just one time, and the corresponding brand and category will also be here. The brand and category can be specified multiple times in their columns, but the product name will only be once. Now let's do the same for the country. So we will say that this is dim country, like a dimension or dictionary of countries. Perfect. Let's keep just those two columns. Let's also deduplicate it. So we want to keep just one combination of country and continent. We won't need more. And now perfect. The last table that we need is the fact table. So this will actually be called fact sales. And here we can remove all the redundant columns that we no longer need because we will have them in dimensions. So we need to keep the product name actually, because so that we can connect to the product dimension. But the brand and category, we no longer need to keep in every row. We can free some storage space and use less space if we just get rid of those two columns. And the same thing goes for the continent. So what we have left here is basically just a transaction table that for this given combination of product and country and year, we have this sales value. So this is the fact table, the transaction table in our specific case. And this transaction table, the fact table, will be connected to our dimensions using relationships. What's more to add here, that you could create similar dimensions for the year if you would have the whole date here as well. So if you would have dates like the 1st of January, 1st of February, and so on, then you could also create a date dimension that would contain attributes such as the quarter, maybe the name of the month and the half of the year, and so on. But for that, let's try to load this data that we have into the model. That will be our first star schema, a small star schema, but a functional one. It will take just a moment to load. Perfect, and now our data loaded. We can see it in the model view. So here we can see that we've got 3 tables. We've got 2 dictionaries, 2 dimensions, and this transaction table, the fact table. And Power BI automatically understood that the relation should be using the product name column for the product, dim product table and fact sales, and using the country name for the sales and country table. So it automatically understands how to connect those tables. If it wouldn't work, you can just drag the columns, the corresponding columns from one table to the other, and the relations will be created. And also, we can just quickly check if this works. So let's drag brand into the visual canvas, and let's also put the sales value here by, let's make it a chart as well. And let's see if our first chart works. So yeah, even though we use data from different tables, they are still connected via relationships. So our star schema, our Power BI understands how to aggregate the data, how to show it to you. So it's a working example and a success. With that, we will conclude for today. Thanks. I hope that you've understood more about the star schema and that this is helpful for you. See you in the next episode.